Hello, AJ. Welcome to our final na review together. And good luck on your exams tomorrow. Alam kong kayang-kaya mo yan. And let me just begin. For our finals review, I started with shear web deflection, yielding, and crippling. So for this one, you only have this formula. You have Vn, that is the shear nominal, is equal to 0.6 Fy Aw times Cv. So the first thing you do is you have to know Cv. So for Cv dito, first you check H over Tw or the depth over the thickness of your web. So pag less than 2.24, the square root of E over Fy, automatic yung CV natin 1.0. Pero if it's greater, doon na tayo magkakaroon ng iba pa. So for Webs-Zobli, you have HW, H over TW, less than or equal to 1.10, square root of KV, E over Fy, you still use CV equal to 1.0. So yung KV, dito natin siya makikita. So for unstiffened webs, we have HW is less than 260, KV is equal to 5. If not, may isa pa tayong formula. And then next we have, if in between siya ng 1.10 square root of KV E over Fy, tapos 1.137 square root of KV E over Fy, ang gagamitin mong CV is this one. You have 1.1 KV E over Fy over H times the thickness of your web. And then lastly, if mas malaki pa siya dito, itong pangalawang part, ang gagamitin nating CV is equal to 151 EKV over the square of H over TW times Fy. So here, for the sign of shear utilization ratio, first, check mo kung ilan yung CV. And to know that, you have H is equal to D over or minus 2F. Ito lang yan. So, pag magdrawing tayo dito, ayan. Ayan. So, this is your H, tong buo. Ima-minus mo lang yung dalawang TF. So, that is if it is flat. Kung rounded, and when we say rounded, natatandaan mo yung may ganyan dito. So, pag ganyan, gagamitin natin yung value ng K. And the value of K would be from the beginning of that rounded portion to the top of your web. So, ito yung K. And this is your TF. Ayan. And then next, check if H over TW is less than or equal to 2.24 over EY. So, pag ganon, gagamitin natin CV is equal to 1. Pag hindi, gamitin natin yung mga formulas from our previous slide. And then, i-check din natin for KV. Ayan. So, pag unstiffened siya, H over TW less than 260, our KV is equal to 5. Pero, kung greater than 260, ang gagamitin natin is equal to 5 plus 5 over A over H. And then to solve for Vn, you have 0.6 Fy AWCV. And then for V, gagamitin natin is 0.9 for LRFD for other provisions. And if it's an I shape, you use 1.0 LRFD. And then last, you have your utilization ratio, that is VU over VN. Usually, our VU is given, that is your ultimate shear. And phi Vn, yung nasolve natin na Vn dito, times the value of phi, which is either 0.9 or 1.0. Then let's move forward. We have design for shear stress. So that is just FV is equal to VQ over IB, wherein V is the force applied in Newton. Q is the area times the moment arm. I usually for square is BH cube over 12. So, pag meron tayong I-beam, ayan, and let's call this B, malaking B. And this is your H. So, ang gagawin mo is PH cube over 12 nitong buo. Ayan. Minus 2 times BHQ nitong maliliit. So, ibabawas natin tong dalawang to get the value of I. And then, simply B is for the base. Ito siya. The base or the total length of your web. Next, ito nilagay ko lang ulit in this PowerPoint para may copy ka. Later, I will send this to you para mas madaling hanapin if you have an open notes na exam. At least you could open this and you have all of this on the list. So you have for uniformly distributed load, uniformly varying load, and you also have your your concentrated load in the middle, concentrated load sa gilid, and then double concentrated load. So it's all here. And then ang mga tinitingnan lang natin here would be Mmax. You also have your deflection. Ayan. Same for the others. So for this one, we always use this formula, WL squared all over 8. And for the deflection, 5WL to the 4th over 384 EI. Yan, madalas yung lumalabas. Okay. Next. Bending stresses for plastic moment. FB is equal to MYIX. Fmax is equal to MC over IX. And that's also equal to M over SX. And lastly, we have My, bending moment to the point of yielding. That is FYSX. So SX dito is a property of the steel, which is always given. If hindi siya given, we could search the web and we could find them. And then I placed this here because this might come out in your exam later. So just in case, at least we have this idea. This is for the bending about the x-axis and the maximum stress and bending moment that brings to the point of yielding. Ayan. Next. Allowable stress along the strong axis bending of I-shaped members. FP is equal to 0.66 Fy. So, compare natin yung makukuha nating FB dito to this value. And then, provided that the flanges are connected continuously to the web or webs and the laterally unsupported length of the compression flange does not exceed the value of LC as given by the smaller of, so pipiliin mo dito yung smaller value, 76 BF over the square root of Fy or 20,000 over D over AF Fy. And then again, I place this here para may copy tayo ng W16. Pero yung mga wala dito sa listahan, we could use those if meron. So here, this is very important. This is a summary of all the formulas commonly used in steel design. So you have the Euler's load and stress. You have column base plate, FP is equal to A over AP. You also have the maximum allowable compressive loads, FP is equal to 0.35 FC. And then here, the one we always use, FV is equal to V all over the area, which is the depth times our thickness of the web. And you'll have your maximum vertical shear, which is VQ over IB. You have your shear flow, Q is equal to VQ over I. And the allowable shear stress. Ayan, so if H over TW is less than 998 square root of Fy, ang gagamitin natin is 0.4 Fy. But if it's greater, ang gagamitin natin, Fv is equal to Fy CV over 2.89. Spacing of rivets, S is equal to Ri over VQ. So R shear capacity of the bolt, V is equal to maximum shear of the beam, Q statistical moment of area. So area nung kino-consider natin times the moment arm, and I is the moment of inertia. And then we also have moment of reduction due to the presence of hole in the flange. So andito lahat yan, and most of this is direct substitution. Next, we have more formulas. FB is equal to MC over I, which is also equal to M over S. Yun yung kanina, M over SX. We also have FB is equal to 0.66 Fy, and all the others that we often use for bending and flexural members. Pag combined naman, tension with bending, you have T over A plus and minus MC over I, bending in one axis. Everything is here. So if you don't know how to use it, you could just send something to the group chat or call out to me. I will be online and we'll see how I can help. Next, we have bending in both axes. So we have this local web yielding and web crippling. Andito rin yung formula. Sideways buckling, andyan na din. So this is really going to help if hindi mo nagawa yung placard natin or index cards na nakalagay lahat ng formulas. This could help you make one. And then we also have for the bearing of plates, axial load with bending. Andito lahat. And then eccentricity loaded columns. And yan, andito yung mga value ng here. Next. So this is an example. Let me pause this for a minute. Okay, so this will be our example number 1. We have an AW 24 by 94 beam is subjected to a shear force of 900 kilonewton. Properties of the section is 17,870 mm squared. T is 616.97 millimeter. Thickness of the web is 13.11 millimeter. BF is 230.15 millimeters. TF is 22.15 millimeters. And IX, or the moment of inertia about the x-axis, is 1,119.7 times 10 raised to 6 millimeters to the fourth. So number 1, we compute for the shear stress at the junction of flange and web. Number 2, compute for the shear stress at the neutral axis. And number 3, compute the shear force carried by the flange. Number 4, compute the shear force carried by the web. And number 5, compute the average shear of the web. Okay. So first, let's go to, there we go. For this one, we have example 1. Shear at the junction and shear at the neutral axis. So when you say shear at the junction, the first one would be, if we consider this area, ang junction natin ay andito. So you have two types. The first one wherein your B or your base is this one, yung malaki. The second one is if your base is here at the bottom. So let's try for the first one, wherein this is our considered area. And so for this one, you have Q is equal to AY bar, wherein A is equal to the base times height. Our base here would be equal to BF, and our height is TF. So ang kinukuha lang natin na area would be this red one. Ayan. So here, let us write down our given. You have your A equal to 17870 mm squared. D is equal to 616.97. TW is equal to 13.11. PF is equal to 230.15. TF is equal to 22.15 millimeters, and IX is equal to 1119.7 times 10 raised to 6 mm to the fourth. Ayan. So let's continue. This is equal to BF 230.15 times TF, that is 22.16. Five, 10, 5,100.124. Okay. And if we solve for our Y, or the moment arm, ibabasa natin to kung gaano siya kalayo sa neutral axis. So if this is your flange or your W section, yung neutral axis natin is in the middle. So this is NA. Okay. So para makuha natin siya, the first thing we need to do is get this height. So we take this height, and this would be equal to D over 2, and ibawas natin yung height ng kalahati kasi ang point natin would be in the middle dito. Ayan. So from that midpoint hanggang dito, we have to get this area. And this is simply 1/2 of TF. Ayan. So to solve for y bar, or the moment arm, this is now t over 2 minus tf over 2. The value of d is given. This is 616.97 divided by 2 minus tf over 2 would be 22.16 divided by 2. Six one six 0.97, 308.485 minus 22.16 divided by 2. $11.08. Ayan. So, i-minus natin. This is 308.485 minus 11.08. Our moment arm would be equal to 297.405. Millimeter. And we could now solve for AY. This is 5,100.124 times the moment arm. So let me write this down. This is Q times 297.406. So Q now would be equal to 1516,802.378 millimeter cube. Okay. So we have QA and our formula for shear is equal to FV is equal to VQ over IB. Ayan. So yung V natin, this is given. If we go back to our question, we have a shear force of 900 kilonewton. So ito, 900,000 newtons kapag kinonvert natin. And we have an I given. So let's IX is equal to 1119.7 times 10 raised to 6. VB, we have the value of Q. So first, let's check our first base. Itong malaki. This base. Ayan. Let's call this FV1. And this is equal to VQ over IB. This is 900,000 times the value of Q, 1516802.378 divided by I 1119.7 times 10 raised to 6 times B. So yung base natin would be equal to BF. This is 230.15. So let's put that here. We have 900,000 times 151,680.378 divided by I. Let me try this again. Yun. So, our answer for 1 is 5.297. Megapascal. And then let's solve for the other junction, itong pangalawa. Yung magbabago dito is the value of our base. So instead of this long one, ang gagamitin lang nating base would be this small one over here. Ito. So let's write that down. Let me change the colors. FV2 is equal to VQ over IB. And yung B natin dito would be equal to your TW, and TW is 13.11. So let us put in our values. This is 900,000 times Q would be the same, 1516802.378 over 1119.7 times 10 raised to 6 times TW 13.11. Okay, so let us put this into our calculator. So this is equal to 'yan. So our FV2 or yung shearing natin dito sa junction would be 92.9961, or this is simply 93 megapascal. Ayan. So, next would be shear at the neutral axis. So, paano naman kung itong buo na siya? Let me move this here. So, ang Q natin magbabago kasi madadagdag na ito. This area. So, for this problem, magkakaroon tayo ng Q equal to A1, Y1 plus A2, Y2. A1 natin, nakuha na natin dito. That is 5100.124. Y1 natin, we also solved. Ito pa rin siya kasi andito yung area natin. This is 297.406. Now let's solve for A2. A2 is equal to this part. Itong maliit na to. So, if the whole thing is D, so if we divide D over 2, ito siya. And if we minus TF, excuse me, if we minus TF, makukuha na natin yung value. And let's call this one small h. And yung base natin would be TW. So the first thing we do is we solve for h. H now is equal to D over 2 minus TF. Pero pag kinuha natin yun, yan lang yung height. And D over 2 would be 616.97 divided by 2. Nakuha na natin yan kanina, and that is 308.485. Minus the value of TF, this is 22.16. So, $308.485 minus 22.16. 286.325. So that is our height. Our base is equal to TW, which is equal to 13.11. We could solve for area 2, which is simply BH. So this would be 13.11 times 286.325. So yung area natin is 3,753.72 millimeter square. 721. Ayan. And then we now know A2. Let's solve for Y2. So, kung yung Y2 natin is in the middle of our area, andito siya. And this is simply kalahati ng H. So, let's continue. Y2 is equal to H over 2. And the value of H is 286.325. So divide natin yan by 2. That is 143.1625. Ayan. And we could now solve for Q. Q at the neutral axis is equal to A1, 5,100.124 times Y1, 297.406 plus A2, that is 3753.721 times Y na 143.1625. Ayan. Okay, so let's put that into our calculator. We have 5100.124 times 297.406 plus 3753.721 times 143.1625. Okay, and Q would now be 2054.199561. Ayan. Okay, so we have Q. Let's solve for FV at the neutral axis. So this would still be equal to VQ over IB. V natin is 900,000. Q natin is 2,054,199.561 divided by I, that is 1119.7 times 10 raised to 6 times B is the thickness of our web, 13.11. Okay. So let's bring out our calculator. Nine hundred. One two five 0.44 So our answer here would be 125.945 megapascal. Ayan. So this is for question number 1 and 2. Shear at the junction, we have 5.297. And you have FB2, that is 93 megapascal. That's also at the junction. And shear at the neutral axis would be 125.945 megapascal. Next, let's go to our next question. Let me clear some of these parts. And so ito yung na-solve natin. So from here, aakyat siya ng 5.31, that's FV1. And then at this connection from 531, aakyat to ng 93. And then our shear at the neutral axis is 125. Ito na yon. And that's it. Okay. So let me erase this. And let's continue with number 3. Number 3 is shear carried by the flange. So let's call that V of F. Okay. And that is simply N over 2 FV1. Kasi ito yung nagbubuhat kanina, itong buong flange. Okay, so let me just put this here. FV1 and FV2. Ayan. So shear carried by the flange is this one. Kasi ang kinuha nating base would be the base of the flange over here. So 230. Ayan. So let's call this shear by the flange is equal to N over 2 FV1 times area of shear. So N over 2, ilan ba yung flange natin? We have 1 and we have 2 divided by 2. So this is simply negligible. So you have FV, V. So this is very familiar. FA to get shear. Okay, FV1 natin is from this equation. So let's put that in. That would be 5.297 times area of shear. This is the base, ito. So that is 230. Or let's call this BF muna. BF times the thickness of the flange, or TF. And then let's put in our values. This is 5.297 times 230.15 times 22.15. And so 27,000 0.3 newtons, or let's convert that to kilonewton by dividing it by 1,000. We have 27 kilonewton. So let's put that here, 27.003. And this is the shear carried by the flange. Let's go to our next question. Shear carried by the web, let's call this VW. And this is simply the total shear minus the shear carried by our flange. Total shear natin is 900 kilonewton minus the shear carried by the flange. This is 27.003. So let us check how much that is. We have 900 minus 27.003. So ang natitira, you have 872.997, and that is how much shear ang binubuhat ng web natin. This is also in kilonewtons. And our last question, we have your average shear of the web. So let's call this VAVE. And that is simply V, or the total applied shear, divided by D times your thickness of the web. Ayan. So we have 900,000 divided by D, that is 616.97, times the thickness of the web, that is 13.11. And let's put that into our calculator. Ayan. And we have an average shear of 111.269 megapascal. Okay. So this is the solution for example 1. Okay. Let's continue. Let me clear this and let's move forward to example 2. Design a W section for a beam of A36 steel with Fy equal to 248 megapascal to carry a uniform load of We cannot see. And let me check my notes. $293 kilonewton per meter. Simply supported span of 1.5. Assume the lateral bracing is adequate for stability. So pag ganito, first we solve for M. And again, that would be equal to, yeah. So step 1, and our moment maximum is equal to WL squared over 8. This is 293 times 1.5 squared divided by 8. You have 83.513 531 kilonewton per meter, or this is in kilonewton meter. And now that we know M, we have FB for bending. We have FB is equal to M over SX. But dun sa mga formulas na binigay ko kanina, FB allowable should be equal to 0.66 Fy. Yung Fy natin is given, so let's solve for FB allowable. We have FB is equal to 0.66. Our Fy is 248. So, makuha natin yung value ng FB. 163.68. And let's plug that into our formula. This is 163.68 equal to 83.531 times 10 raised to 6. This is your M over Sx. So you will solve the value of Sx required here. And so cross multiply, we have Sx is equal to 83.531 times 10 raised to 6 divided by 163.68. So the value of our Sx would be 510,331. 0.9, or you could round this up, 0.134. Okay, and then let's check yung mga given nating wide flange and compare the closest to SX. Ayan. So you have your 560.4, you have your 674.3, and you have your 575.2. And we choose the closest one, so it would be the most economical na value of the section modulus. So we're going to try W12 by 27. Okay, so let's continue. Let's write our given. You have the weight of beam, 394.9 Newton per meter. You have the area, this would be 5129. You have your depth, that is 303.78. And you have your PF, this is 165.02. You have your TF, thickness of the flange, this is 10.16. Thickness of the web is 6.02. Inertia is 84.9 times 10 raised to 6. And you have your section modulus, 560.4 times 10 raised to 3. Okay, so let's use this given to check if it is capable to carry the load. So first, let us solve for W total. Kasi meron tayo ditong W, or our uniformly distributed load, of 293 kilonewton per meter. Pero may isa pang binubuhat yung beam natin, which is the self-weight. And self-weight is given as 394.9 Newton per meter. So if we convert this into kilonewton, so i-divide lang natin siya ng 1,000 newtons per kilonewton. So this would be 394.9 divided by 1,000, 0.3949. And to get the total weight, this is just 293. That's 0.3949. This would be 293.3949 kilonewton per meter. And then, ganun ulit. Let's solve for the FB actual. So to solve for FB actual, this is just the moment divided by SX. So yung moment natin is WL squared over 8. W total natin is 293.3949. Our length is 1.5 meters. Quantity squared divided by 8. So let us put that here. 293.3949 times 1.5 quantity squared divided by, and you have 82.517. This is your M. And SX is given as 560.4 times 10 raised to 3. So direct substitution from here, you have 82.517 times 10 raised to 6 divided by SX, which is 560.4 times 10 raised to 3. And FB would be 147.247. Okay, so let's check if it's safe. F allowable is equal to 0.66 Fy, and that would be equal to 0.66 times 248. So our F allowable would be equal to 163.68 megapascal. And since our FB actual is less than FB allowable, then we can use W 12/27. Okay, and that is it for example 2. So The next thing we do is we check if it is safe for shearing. So this is h over the thickness of the web equal to yeah. So let's see what are the values. Yeah. So to know the value of h, this is simply the value of d minus the thickness of the flange times 2. So this is 303.78 minus 2 times 10.16. $283.46. And then the next thing we do is put that in our formula. So this is 283.46 divided by TW, that is 6.02. And we have 47.86. Then we compare it to square root of Fy. So you have 998 divided by Fy natin is 248. And you get the square root of Fy. Ayan. And this is now equal to 63.373. Therefore, this is less than this. That means we use FV allowable equal to 0.4 Fy. So let's solve for that. FVL is equal to 0.4 times 248. You'll get 99.2. And then let's compare this allowable to our actual. And to get the actual, you have P is equal to FVAV. But how do we get P? We have your value na P is equal to WL all over 2. W is the total W plus self-weight. So that would be 293.3949 times L 1.5 divided by 2. So our P actual is 220.46. And we have P, we have AV. For AV, we could solve for AV. So let me move this calculator and let's solve for AV. AV is just the T times PW. So this would be D natin is 303.78. PW natin is 6.02. One eight. And then we could solve for FV actual. So you have FV is simply equal to P over AP. Ang P natin is 220.046 and this is in kilonewton. So let us convert that to Newton by multiplying it to 1,000 and let's divide this by the value of AV na 1,828. So let's put that into our calculator. It is 0.046 times 1,000 divided by, so you have 120.325. FV is equal to 120.325. Let's compare this to our allowable 99.2, therefore unsafe. So do not use W12 by 27. So what do we do next? Let us use the next one on our list. And that would be W14 by 26. Ayan. So, palitan natin to. For W14 by 26, the weight would be 380.27. Area is 4948. Depth would be 352.81. BF, dito tayo nagko-compare. That would be 127.64. TF is 10.62. TW is 6.48. I is 101.56. And SX is 575.2. So we are now considering this web kasi itong una ay nag-fail. Yeah. So let us start again for the next web. So dito muna tayo. First thing we do is solve for W total. Yung self-weight natin magbabago, instead of 394.9, magiging 380.27 Newton per meter. And then, ang sagot dito is 38027. Ayan, so ito 803, and this is now 3803. Then let's solve for the actual moment. So magiging 293.3803 times 15 times 8. Magbabago tong value na to. So that would be 293.30 293.3803 times 1.5 quantity squared divided by 8. So you have 82.513. So magbabago to, 513. Our SX magbabago rin, that would be 575.2. And let us put that into our equation. That would be 82.513 divided by 575.2. And magbabago itong value ng FB natin. Divided by 575.2 times 10 raised to 3. $143.451 megapascal. And our allowable would be 0.66. So our actual is less than our allowable, so it is safe. Let us use 14 by 26. Ayan. Tapos check ulit natin if safe for shearing. H is equal to T over W. Magbabago tong value na to. Let us first solve for H. This is 352.81 minus TF. That is 10.62. 62. So this would be 331.57. And this is now 331.57 divided by TW 6.48. 51.168. And let's check if it's smaller than 998 over square root of Fy, and it is still smaller. So ang gagamitin pa rin natin is Fv allowable 0.4 Fy. So let us solve for Rp. This is now 293.8. 3803 times 1.5 times 2 times 1.5 divided by 2, 220.035. Okay, so let us check for AV. That is D times TW. D is 352.81. TW natin is 6.48. So magbabago to. Ayan. And this is our new AV. So this would be 220.035 times 1,000 divided by our new AV, 2286.2208. So pagbabago yung actual FV natin. So let us put that here. And our FV now would be equal to 96.244 megapascal. Ayan. And pag chinek natin, dito sa allowable, mas maliit siya. Therefore, it is safe. So, this one is safe. Therefore, we use W 14 by 26. Ayan. So, this is it for example 2. So, let me clear all the drawings. And for example 3, it is the same concept. I will leave this to you. So we could move to the next topic, which is bending in both axes. So for bending in both axes, binigay ko na yung step-by-step formula. So first, cross-section classification, KLX over RX, slenderness KLY over RY. And we also have FE, FCRPN, and available strength. And then we have bending in both axes. We solve for CV, we have LR and LP. So yan, formulas lang and then direct substitution. So this is an example. We have AW 250 by 58, A36 steel. Column is pin connected at the top and bottom with sideways being prevented. The upper hinge is eccentric by 25 millimeter, causing bending about the major axis. Column is 5.4 meters high without any lateral bracing using NSCP specification. So, pag tinignan natin tong area na to, this is a pin and this is also a pin. So, pag pin connected, K would be equal to 1. Ayan. Okay. So, from there, let us solve for KL over R. In the X and Y direction, let us solve for the critical load. Let's check for the flange, check for the slenderness, solve for FCR, solve for PN, MN, and check for compaction, then solve for lateral torsional buckling. And so first, let us check for flange. And this is equal to BF over 2T F. And we will compare it to 0.56 times the square root of E over Fy. And so first, let's check BF over 2TF. BF natin, that would be 203. 2TF natin is 8. So 2 times 8. You have 12.6875. And then let's check 0.56 square root of E over Fy. A36 steel, so Fy 250 is 200,000. And we get the square root times 0.56. We have 15.89839. Ayan. And then now that we have this, that means BF over 2TF is less than 0.56 square root of E over Fy. So, pag ganyan, that means it is compact. So, it is also not slender. Let's check naman for the web. So, pag web ang gagamitin natin, we have H over T, the thickness of the web, and we compare that to 1.49 the square root of E over Fy pa din. Let's first check for H over TW. H is 252 minus, that would be TO minus 2TF. 252 minus 2 times 8. This is 236. And then let us now solve for H over TW. This is now 236 divided by TW is 13.5. So this is 17.481. And then let us check for the square root of 1.49. E over Fy. E is 200,000. Fy is 250. This is 800. We take the square root. And we multiply it to 1.49. This is 42.143, which is greater than H over TW. Therefore, it is compact and it's also slender. Next, we check for the slenderness. So slenderness ratio is equal to KL over R. So we have 2, that is slenderness ratio about the x-axis. So we just use KLX, or simply KL over RX. And you have the slenderness ratio about the y-axis. This is KL over RY. So for this case, our K is 1.0 since it is pin connected. So that is 1 times our length, ito, 5.4 meters. So let us convert that into millimeters, magiging 54,000 divided by Rx. So Rx natin is 108. So let us put that in. You have 54,000 divided by 108. you have 500. And you now have Ry. So this is 1 times 54,000 divided by Ry 50.4. You get 1,000. And then what we do now is we choose the higher value. SR, which is 1071.428. .4 meters. Times 1,000. My apologies, may mali tayo dito. This is 5,400 lang. So this should be 50 and this should be 107.143. Ayan. Okay. And then let's solve for FE. So FE would be equal to pi squared E over your slenderness ratio squared. So this would be pi squared times 200,000 divided by 107.143 quantity squared. Ayan. So let's solve for that. We have pi squared times 200,000 divided by 107.143 squared. And our answer for FE would be equal to 171.95 megapascal. After that, let us solve for FCR. Ayan. So when we're solving for FCR, let's first compare our slenderness ratio to 4.71 square root of E over Fy. So let's do that. We know that our slenderness ratio is 107.143. If the slenderness ratio is less than 4.71 square root of E over Fy, ang gagamitin nating formula is FCR equal to 0.658 raised to Fy over Fe divided by Fy. If this is greater than the FCR, ang gagamit, then 0.71 square root of 200,000 divided by Fy, ang gagamitin natin is 0.877 Fe. So let us check. This be 4.71 square root of 200,000 divided by 250. So, ang sagot natin is 133.219. So, this is now less than. At dahil less than siya, ang gagamitin nating value is equal to 0.658 raised to Fy over Fe times Fy. Ayan. So let us simplify. This is 0.685 raised to Fy natin is over here, 250. Fe natin, we solve that as 171.95 times Fy. 685 raised to 250 divided by 171.95 times 250. Our critical FCR would be equal to 144.228. So that is the value of FCR. Then let's solve for PN. So PN is simply FCR times the area cross. FCR natin is 144.227. Area cross natin is given as 7,420 millimeters squared. So direct sub. You have 10164 0.34 newtons. And let us convert that. Then we have 1 point, or simply 1,070.16 kilo Newton. Ayan. And then next, we check for M and X and M and Y. For M and Y, this is simply 1.6 FYS Y. So this is 1.6. Fy natin is 250. Sy natin is over here on this table. That is 186. So we have 1.6 times 250 times 186, 74,400. And then this 186 is in millimeter cube. So let us multiply it to 1,000. So this is Newton per millimeter squared times millimeter cube. So this would be 74,400 Newton millimeter. So we divide it by 1,000 to make it kilonewton millimeter, and we multiply it to 1,000 to make millimeter meter. So 74 Nm times in 1 kilonewton divided by 1,000 Newton times M. So in 1 millimeter, we divided by, so divided by 1,000 meters, millimeters per meter. Times 1 kilonewton over 1,000 Newton, so divided by, and times 1 meter over 1,000 millimeters divided by 1,000 again. That is 0.0744 kilonewton meter. Next, we have M and X. And this is Fy, say X. Fy natin is 345 megapascal. Zx, let's look for Zx. That is over here. So 770. That is 265.65. So let us convert that into kilonewton meter. Two 0.2656. And then let's check for your LP and LR. So for LP and LR, direct substitution lang yan. Hanapin mo lang yung values dito. And then, tapos na tayo. You check for compaction. You have 0.38 square root of E over Fy and 0.36 over times square root of E over Fy. And that's it for axial and tension together. So I will let you continue this problem. So we could go now to our last one. We have bolted connection. So for bolted connection, this is just a review because the steps is the same for everything. We have a W 300 by 67 has two lines of 20 mm diameter bolts on each flange, 3 bolts on each line which has a spacing shown. So ito siya. A36 steel is used with Fy equal to 250 megapascal. Fu is equal to 400 megapascal. A is a 250. BF is 201.05. TF is equal to 14.40. D is equal to 300. And TW is equal to 8.4. Next, we only have 3 questions. We look for the effective net area of the section. Number 2, we look for the allowable tensile strength of the section. Lastly, we compute the block shear of the section. And okay, so let us continue. Ayan. So first, ang hinahanap is the effective net area. So the effective net area, ang given sa atin is the diameter of the bolt hole. Pag tinignan natin dito is 23. So let us also write that here. And to solve for the effective net area, we first solve for the net area. So let's call that AN. And that would be equal to the gross area minus the number of bolts times the diameter of the bolt hole times the thickness of the flange. So given lahat to, we have AG 8250, number of butas natin. So ang titignan natin is the cross-sectional area. So we have over here, you have 1, 2, 3, 4. So apat. Yeah. So this is now 4 times the bolt hole 23 times the thickness of 14.40. 8250 minus 4 times 23 times 14.4. So we have AG, or the effective net area AN, equal to 6925.2. And then to get AE, this is UAN. Ang tatandaan lang natin, if it's an I-beam, or let's call this U or WMS shape, we first check BF over D if it is greater, equal to, or less than 67. So if it is greater and or equal to 67, ang value ng U natin is 0.9. Pero if it is less than 67, use U equal to 0.85. So let's check. BF over D. So BF natin is 201.05. Our D is 300. That is 0.67. Sorry, correction. This is 0.67, 0.67. Ayan. So this is equal to 0.6701. Or that is 0.67. Sakto. So ang U na gagamitin natin is equal to 0.9. Therefore, the effective area is equal to 0.9 times AN. And we have solved the value of AN as 6925.2. So our effective area now would be equal to 6,232.68. Ayan. So that is the value of AE. Also, so this is for W, M, or S shape, or usually this is our I-beam, itong mga to. Pero pag ang gagamitin natin for plates, U is equal to 1. That's why for our bolted connection na hindi I-beam, yung plate on plate, ganon, ang ginagamit natin, AE is equal to AN kaagad. Wala na tayong U. Pag ganito, na pag ang side view naman natin ay I-beam, dun lang tayo gagamit ng U. Okay, so that is for your effective area. Let's go to your next question. Allowable tensile strength of the tension. So for tensile, strength, we have two. We have your gross area, and your net area. So for your gross, P here is equal to 0.9 times 248 times, or this is 0.9 FYAG. FY again natin is 250. So this is equal to 0.9 times 250 times 8250. So yung P natin when it comes to our gross area is equal to 1,856,250. Or this is simply 1,856.25 kilonewton. And then for our net, P is equal to 0.75 FUAE. So this would be equal to FU 400 and AE, that is 6232.68. So let's put that in. We have 0.75 times 400 times 6232.68. So that is 1869, 1804. Or divided by 1,000 to get this in kilonewton, this is simply 1.869, 1,869.804 kilonewton. Okay, and then from here we choose the smaller value, therefore the tensile strength is equal to 1856.25. And then lastly, let's go to our last question. Compute the block shear of the section. Ayan. So, block shear na tayo. Let me erase this. Ayan. So, for block shear, we have two. The block 1, FVAB plus FTAT plus FT. And yan. And we also have FVAG, FTAT. Okay. So, let's solve for block 1. Ayan. So, pag block 1 yung gamit natin, FV is 0.6 FU. Therefore, this would be 0.6 times 400. And this is equal to 240 megapascal. And then, for block 1 also, our FT is equal to 0.5 FU. So this is 0.5 times 400, and that is 200 megapascal. Next, we solve for the area of shear, AV, and that would be ito sa taas at sa baba. This area and this area. So AV would be your total length minus your bolt hole. So length of shear minus bolt hole diameter. And then dahil meron tayong dalawa sa taas at sa baba, so we multiply this by 2. So this would be equal to 2 times the length. Total length is 200 minus the bolt hole. So we have 1, 2, and 1/2 dito. So that would be 2.5. And our bolt hole is 23. So 2 times 200 minus 2.5 times 23. And then we multiply this to the thickness para maging area siya. So this is times 14.4. Makuha na natin yung value ng AV, and that would be equal to 4,104 millimeter. Next, let's solve for 80. 80 is the length of tear. And dahil meron tayong tearing sa taas at tearing sa baba, we multiply it by 2. So that is 2 times the length of tear, let's call that LT, minus the bolt hole, times the thickness. So 2. Ang length of tear natin is from here to there. So that is only 32 minus bolt hole natin. Dito ay kalahati lang. So that would be 0.5 times the bolt hole of 23. And we multiply it by the thickness of 14.4. So 80 natin dito is 590.4. And then let's put that into our formula. We have P, our phi there is 0.9 times FVAV plus FTAP. There you go. So let's put in our values. This is 0.9. FV is 240 times AV is 4104 plus FT, that's 200, and 80 is 590.4. Ayan. Okay, so P would be equal to 992.736 kilonewton. So that is for block 1. And then let's try block 2. Okay, so for block 2, our FV here would be equal to 0.6 of Fy. Our FT would be equal to Fu. Ayan. So that would be 0.6 of 250. That is 150. And Fu here is 400. Area gross is equal to 8250, and area tear would be the same as block 1, so that would be equal to 590.4. Ayan. So we have all we need for block 2. Let's put that into our equation. This is P equal to 0.9 times FVAG plus FTAT. Ayan. Then let's plug in our values. We have FV 150, AG is 8250 plus FT 400 times 80, that is 590.4. Ayan. Okay, and to get our block shear, this would now be equal to 0.9 times 150 times 8250 plus 400 times 590.4. And the answer would be 1326.294 kilonewton. Ayan. And then we compare them both sides and choose the lower value. Therefore, our block shear would be equal to 992.736 kilonewton. And this wraps up our review for the finals. I will give you a copy of this so you would also have a copy, or you could also try to exercise with all this given. You will have a copy of all the formulas that we need and how to approach. You could answer example 3, and when you're done, you could ask me for the answer para ma-compare mo if it's correct or not. Ayan. And then next, these are the formulas here. So almost everything would be here, including the yielding and crippling. Ayan. And additional formulas that we might need. Okay. And this would be the end of our finals review, and good luck on your exam. I believe in you, AJ. Kayang-kaya mo to. I will stop the recording and send this to you.